Hi students, so now we are going to discuss the topic of calculation of areas by analytical method, that is average ordered method. So it is in the chain surveying. So these methods are very important. So on completion of this topic, the student will be able to know compute the area enclosed between the chain, baseline and an irregular boundary by analytical methods. So let us see the what are the analytical methods are there. Let us see now. So once we see in the previous class that method of preparing site plans by chain surveying. So here, how do you find the area of a regular geometrical figure? So first of all, these methods are why we are using. So we have seen now up to now the chain triangulation methods by calculation of well condition of triangles, and we have seen the errors in chain surveying, calculation of errors in correct length and true length of lines. Now we are going to see the finding the area by the different types of methods. So example, you can see how do you find the area of a regular geometrical figure, for example square, rectangle, triangle, etc. So that is answered by mathematical formula. You know everyone, with the help of mathematical formulas we will find the area of a square, rectangle and triangle. So like that, in case of irregular areas, that means irregular areas means it will be like zigzag in this type. Okay, these are all irregular areas. They are not to shape. They are not to any equal shape. So how do you find these type of areas? So let us see here. Introduction. It is necessary to calculate the areas after the land survey is carried out in the field like plots, revenue lands, etc. So it is necessary to calculate the areas after the land survey that is carried out in the field like plots, revenue lands, etc. So in case of irregular areas enclosed, that is between the baseline and an irregular boundary, there are certain methods available to calculate the areas. Okay, so here in case of irregular areas, that is between the baseline and irregular boundary, so this is the irregular area. So the baseline which will be there, it is a chain line. Okay, so here between the irregular boundaries, in these cases we will be, now let us have a look at them. So what are the methods? This is very important. There are different methods available to calculate the areas of irregular boundary. So let us see what are the methods. The first one is analytical methods. Analytical method is one of the method is used for the calculation of areas. Second one is graphical methods. The another method is graphical method, which is used for the finding the area of the irregular areas. Third one is instrumental methods. So this is another type of method which is used for the calculation of boundary areas. And so let us see these are the three methods we are using in the chain surveying. Let us see one by one. Analytical methods. So there are four different analytical methods to calculate areas of irregular shape. So in analytical method, again there are four methods. One is average ordinate method. Second one is mid ordinate method. And the third one is trapezoidal method. and the fourth one is Simpson's roll method. So remember, these four methods are used for the calculation of areas for irregular shapes. So these four methods are also called analytical methods. So let us see the first one. And in graphical methods, there are following are the different graphical methods. So let us see here. The first one is by division into triangles. The graphical method sum will be by division into triangles. And the second one by division into squares. Okay. So some of the graphical methods, they will be by squares also we will be taking on. And the third one is by division into trapezoid. Okay, some methods will be by trapezoidal we will be doing on. So let us see these methods. And next one is instrumental methods. Instrumental method by using an instrument called planimeter. So here this is called planimeter and it is also called minor instrument. Areas of irregular shapes can be calculated. So by using this planimeter, we can calculate the areas. So let us see the first method, average ordinate method. So in this method, the baseline is divided into number of equal divisions or equal parts. Okay. So in the name itself, you can see average ordered method is divided into the number of equal parts. Watch, this is the baseline will be divided. So here, and ordinates are drawn at a point of division and measured. So the ordinates, the points which are there, they will be drawn at a point of division and they will be measured. So let us see the diagram here. So this is the average ordinate method diagram. So here you can see the diagram, it is mentioned O1, O0, O1, O2, etc. are ordinates at each of the division. So this is the chainage line which is started. Okay, we will call it as baseline. Okay, and this is the irregular boundary surface on the ground. So we are taking the points, that is O0, O1, O2, O3. So O1, O2, O3 are called the ordinates at each of the division. And capital L is the length of the baseline. And the small d is common interval, that is nothing but the distance between the ordinates. So it is taken same distance. Suppose if it is taken 5 meters, so then O1, O2 also should be 5. So that's why the small d is called common interval. And the small n is the number of equal parts it is divided. So how many parts if we divided? Let us count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the number of parts is equal to n is equal to 10 parts it is divided. Okay. So to get the irregular boundary surface area, we are using this method. So here O0 means ordinate at 0 chainage. So the chainage will be started from 0 to something at 30 or 40 or 60. Okay. So we will be taking 0 to some distance. So O1 means ordinate at first chainage and so on. This is first chainage and so on. That means from 0 to 5 meters it is 5 meters chainage. So again 5 plus 5, it is 10 meters. So 10 plus 5, 15. Like that it will be going on 30 meters or 60 meters or going on. It's depending on length. So we are taking at different intervals. So here we have to use in this point, the change point, first point will be the keeping the arrows, okay, and the last also should be keeping the arrows. So in between ordinates we have to keep the arrow points O1, O2, O3, O4, O5, O6, O7, OH, O9 and O10. So we have to keep the arrows and the straight chain should be kept here, okay. On the chain, on the baseline, we have to keep these common points, okay. We have to keep the chain line like this, and with the help of tape we have to take the measurements for 1, 2, 3, 4, 5 like this. These are the ordinates we have to take. So after taking these points we have to divide it into the equal number of parts. So now let us see here. Therefore delta area is equal to average of ordinates into length. So here the first one is the area which is there, that is average of ordinates into length. So area, to find out the formula, area is equal to O0 plus O1 plus O2 plus of On. That means the number of ordinates by n plus 1 into L. So what is L here? So L is the length of the baseline. This is the total length of the baseline. This we have to remember. Okay. So that's why the irregular boundary which is there, we have to keep the ordinates with the common interval. So this should be checked compulsory while we are taking the measurements. So if the interval becomes very long or very too short without any combination, so the measurements will become, calculations will become wrong. So this type of problems will occur. So we have to take the common intervals, and after that we have to divide it into the number of equal parts as per depending upon the ordinates. So these ordinates are taken at common intervals. So that's why this is called the baseline. So this baseline also should be straight and it should be checked correctly. So here this is the formula for calculating the area. So let us see. O0, O1, O2, etc. are the ordinates. So n is equal to a number of divisions. So how many divisions we have done, that we have to check it. So L is equal to length of baseline, that is n into d. Okay. So how many number of divisions we have came, so we have to take. Suppose number of divisions are given 3. So 3 into the distance we will get. So d is equal to common distance between the ordinates. So this we have to apply here. So here procedure to calculate the area by average ordinate method. So first of all we have to find the total length, that is L is equal to n into d. So here n is equal to number of divisions, d is equal to the distance between the ordinates. Then next find the average of all the ordinates. We have to find the average for all the ordinates compulsory, okay, and we have to apply the formula. So then we will get the correct answer. So first of all, to find the total length we have to know the number of divisions and distance between the common ordinates. So let us see an example. The following perpendicular offsets were taken at 30 meters intervals from a baseline to an irregular boundary. So that means the diagram, you remember how it is. So at 30 meters intervals he has given already. Okay, that is from a baseline to a irregular boundary. So the 30 meters means what? You have to remember, that is D. The D is called 30 meters intervals. It is the common. It is the common distance between the offsets. And the offsets are 5.9, 12.4, 16.5, 15.3, 18.4, 20.9, 24.2, 21.8 and 19.2 meters. So now calculate the area in square meters enclosed between the baseline and the irregular boundary line by average ordinate method. So if the question was given like this, you have to draw the diagram compulsory. So you have to draw the diagram and you have to identify. So the first chain edge line which is given, let us see here. So this is our baseline. So say it is the point A, say this is the point B. Okay, so on this baseline the starting point, chain edge point is 5.9. Okay, so this is a 5.9. And next, so this 5.9 should be taken from this height. How much it is? It is 5.9. Suppose you take with the scale 5.9 meters height. And again next point is 12.4. So that will be here. Okay, so this 12.4 will. So here what is the distance between these? The 30 meters. Then we have to draw a line like this. Then again next common distance is 30 meters. Then you see 16.5 rises here. So the 16.5 it is here. Then you draw this one. So it will be going on up to the 19.2 meters. So you can see the diagram also. So the diagram was not given, but I will draw this diagram. So next, after 16.5, again you take the interval of 30 meters. So this should be the common point compulsory. These 30 meters should be taken compulsory. Then again from 30 it should go 15.3. Then you draw this line. Why? Because 16.5 is greater, 15.3 less than. Then now again you take 30 meters distance, draw the more than 16.5. It will be the 18.4. So now attach this line 15.3 to 18.4. Okay. Then after again you take it some distance, that is more than 80.4, that is 20.9. So from here it will be joined. And again after 20.9, more than it is 24.2. So join this. And now another one is 21.8. So join this one. And at the last point is, that is 19.2. So this one join. So now we have got the irregular surface levels. So these are all the levels which are taken, irregular surface with the instrument. So these, and with the every intervals of 30, the perpendicular offsets were extended. Okay, so this will be the, if you do this one, 30 plus 30 60, 60 plus 30 90, it will be going on increasing. It will be the total length. So now let us see first one thing, that is interval between the offsets d is equal to 30 meters. Okay, so number of offsets, how many we are getting? 9. So let us count here how many are there. So 1 2 3 4 5 6 7 8, but we are getting the 9 offsets. So that is one we are missing here, that is it will be starting from 0. I have forgot. So 1 will be the 0. So this is a 0 point. Okay, 0 to 5.9. So that means 1 here it will be there, 2 here it will be there, 3 here, 4 this one, 5 6 7 8 9. So now we have got the 9 offsets. So starting from 0 it will be there. So we have to take compulsory, the chainage will be starting from 0. We have to remember whether it is not given or not, we have to take from the 0. So now we have got the 9 offsets, and number of equal intervals n is equal to n minus 9 minus 1 is equal to 8. So why we are doing the n minus 1 is equal to 8? Because the equal intervals which are there given as per the measurements are how many? 1 2 3 4 5 6 7 8 9. Okay, so the outside offset is the 19.2. Where is the last distance? So that's why we are taking 9 minus 1 8. Okay, so the now length of the baseline L is equal to n into d, that is 8 into 30 is equal to 240 meters. We will get the length is 240 meters. So we are calculating the intervals, that is as per the formula L is equal to n into d. So this n is the number of offsets and d is the distance between the common intervals 30. So if you do 8 into 30, we will get the 240 meters is the baseline. So from where it will be there, 240 meters. So this will be the 240 meters length up to here. So now let us apply the formula. Area is equal to O0 plus O1 plus O2 plus On by n plus 1 into L. So applying this formula, let us see here. Area A is equal to, so what is this O0? The first one is 5.9. So where is the first one? So this is the 5.9 first one. We are not taking the 0. So because 0 length will be not considered. So 5.9 is 0 plus 12.4, that is A0 plus A1 12.4. The next plus 16.5 plus 15.3 plus 18.4 plus 20.9 plus 24.2. So like that we have to add the all, plus 21.8 plus 19.2 divided by 9, because totally 9 offsets are there. So we have to do divided by 9 into 240. So what is this 240? This is the length of the baseline. So if we substitute this one, we will get the answer as 4122.67 meters square. So this is the process used in the average ordinate method to calculate the area. but we have to take the carefully these offsets and ordinates compulsory, because these common intervals should be checked compulsory each and every between the offset. If one length also will be changed, we may the area also will be changed. Note, if the last division is short of equal division, then the area is to be calculated separately and added. So this point we have to remember. If the last division is short of equal division, last division means, so here this is the last division 19.2. Okay, so if it is short of equal division, then the area is to be calculated separately and added. So this is the problem of average ordinate rule method. So you solve the more somewhat examples regarding this. So let us see now the next method, calculation of areas by analytical method, that is called trapezoidal method. So objectives, on completion of this period you will be able to know calculate the irregularly shaped areas by trapezoidal method. So in the last season we have discussed that is finding the irregularly shaped areas by average ordinate method. So trapezoidal method, what is it? This is more accurate method than average ordinate method. So why it is accurate? So let us check. In this method, the area is divided into a series of trapeziums. So here we will divide the area into a series of trapeziums. So this rule assumes that the boundaries between the ends of ordinates are straight lines. So in the average ordinate rule, we have taken the ordinates between the intervals perpendicular offsets, but here the boundaries between the ends of the ordinates will be straight lines. So here you can see the length L is the length of the baseline, and as it is O0, O1, O2, O3, so up to ON, these are all the ordinates. So this is the irregularly bound line which will be there, and here the straight line will be there which is used, okay, which will be connected in the trapezoidal shapes, that is O0, O1, O2, X3 are ordinates at each of the division. They are the ordinates at the each of the divisions. These ordinates are compulsory should be marked with the arrows. So these ordinates should not be missed with the common intervals. So here L is the length of the baseline and N is the number of equal parts into which it is divided. So this is the N will be the common. How many parts if you are dividing, you can see. So let us see here. So now the formula will be changed. Delta area is equal to D into sum of first ordinate plus last ordinate by 2 plus sum of the remaining ordinates. So here what is first ordinate? This is the first ordinate. What is the last ordinate? Wherever you are getting ON, this is the last ordinate by 2 plus sum of remaining ordinates. That means area is equal to D into O0 plus ON, that is N means the number of ordinates, by 2 plus O1 plus O2 plus O3 of ON minus 1. So this is the formula which is used in the trapezoidal section. Okay, this is used for the trapezoidal method. So small d is equal to common distance between the ordinates. This will be the common distance. So it will be not any other distance which will be there. So here O0, O1, O2, O3, etc. are the ordinates. So let us see the procedure to calculate area by trapezoidal method. So first of all, observe the interval between the offsets. So first of all, we have to observe the interval between the offsets. How much the interval offset gap is there. The next, if the interval is regular throughout, find the total area by applying formula. If the interval is regular, that means the common distance is same. We have to find the total area by applying formula. Let us see the formula, that is, if the interval is not regular, okay, the baseline may be divided into different sections of equal interval. So in such cases, another idea also will be there. That is, this you see example here. This is the lane is there. Suppose it is the a 30 meters length. So we have not taken the offsets, that is ordinates length commonly. We have taken unequal length. So if you not keep in the ordinates, you divide it into the number of parts. How many parts you require, you can divide. That means 30 divided by, we need the 8 or 9 parts, to 30 divided by 9. Then you will get some distance. So from starting point, you keep the same distance and make it as d. This will be the common interval, and same like the next one also common interval. So this will be happen in such cases if the interval is not regular. Okay, so that we will be make it into the regular form. And next is compute the areas of each section and add them to get total area. So we have to add them to get the total area. So for example, let's see the problem. When divisions are made with equal interval, suppose, okay, the following perpendicular offsets were taken at 30 meters interval from the baseline to an irregular boundary line. This is the from the perpendicular offsets were taken at 30 meters interval from the baseline to an irregular boundary line. So 5.9, 12.4, 16.5, 15.3, 18.4, 20.9, 24.2, 21.8, 19.2 meters are the given offsets. So calculate the area enclosed between the boundary and baseline by trapezoidal method. So here, if they are not in the common intervals, we have to make it in the common intervals. But if the distance are with equal interval, let us see here, it is given that the interval is uniform throughout. That means throughout the length, it is the intervals are common. So applying trapezoidal rule, area is equal to d into O0 plus On by 2. What is O0? It is sum of let us see here once again, sum of first ordinate plus last ordinate by 2 plus sum of remaining ordinates. So same here, the formula is applied here. Sum of first ordinate plus last ordinate by 2 plus sum of other ordinates, that is O1, O2, O3, On minus 1. So here let us see the common interval is D30. The first one is 5.9 and the last one is 19.2 by 2 plus the remaining ordinates which are there, that is 12.4 O1, 16.5 O2, 15.3 O3, this is O3, 18.4 O4, 20.9 O5, 24.2 O6, 21.8 O7. So totally here this is O0 plus ON means O0 plus O8. So these are the offsets we have taken, is equal to 30 into, add all these things, 12.4 plus 16.5 plus 15.3 plus 18.4 plus 20.9 plus 24.2 plus 21.8. Okay, we will get 142.05. Okay, so after that divided by 2 here, so this you do this one, so we will do the calculation also for clear understanding. So that is, first you do the 5.9 plus 19.2 divided by 2, we will get 15.5. Then after you do 15.5 plus 12.4 plus 16.5 plus 15.3 plus 18.4 plus 20.9 plus 24.2 plus 21.8, then we will get here 145. It is not the 142.05, it is, the answer is 145. Okay, now 145 into 30, we will get 4261 point meter square. It will be changed here. So 30 into closure brackets, you take 145, we will get 4350 meter square. So this answer will be 4350 meter square. This is the area of the taken offsets lengths. So meanwhile these corrections will be happen. So but this interval is uniform throughout, compulsory. So remember this formula. Trapezoidal rule formula is O0 plus On by 2 plus O1 plus O2 plus of On minus 1. Sum of first ordinate plus sum of last ordinate by 2 plus sum of other ordinates. It is very simple for the calculation. Let us see the problem number 2. When divisions are made with unequal intervals, suppose the following offsets were taken from the survey line to a hedge, that is, this is another problem we can see here. So distance is given, we have to calculate this one. So I will be explaining you this problem in the upcoming next class. So let us once revise only this problem. So if the necessary corrections are there, you make it. So we have seen now average ordinate rule and trapezoidal rule. So these two methods are used for the calculation of unequal areas. Remember, calculation of unequal or unable to do the areas which are there. So that's why these two methods are very important. Okay, so these are problems which are there used in the land areas. In land, we will be doing this type of methods. Okay. So in the next class, we will see the problem number 2, that is of another method with unequal interval. Okay. So I hope understand everyone. Thank you. Have a nice day.